Hello students, welcome to Drona Edu. I am Manjushri. In this class, I am going to teach 8th standard science chapter 14 chemical effects of electric current. For this experiment, we will need a copper sulphate solution. Okay, we need copper sulphate solution and copper plates, okay, copper strips. Okay, it will be around size of 10 centimeter into 4 centimeter area. Okay, 10 centimeter into 4 centimeter. We have taken copper sulphate solution and also copper strips, which is around 10 centimeter into 4 centimeter in the length and breadth. Right? We have both of them. Now take 250 ml of distilled water into a clean beaker. Okay. Now dissolve 2 spoonfuls of copper sulphate into it. Okay, in the distilled water, you are putting 2 teaspoonfuls of copper sulphate in it and making it copper sulphate solution. Okay, add few drops of dilute sulfuric acid to this copper sulphate solution so that it will be more conducting. Okay, when copper sulphate solution will be more conducting or the better conductor, when you will be adding some amount of acid in it. So you are using dilute sulfuric acid into this copper sulphate solution. Did you understand? Clean copper plates with the sandpaper. You have to clean it because there will be oxidation on the copper plates. So you will be cleaning it with the sandpaper. Okay, so that there will be no oxidation on the plates. Now rinse them with water and dry them. Okay. Now what you are going to do is, you are connecting this copper plates with the terminals of the battery and going to immerse it inside the copper sulphate solution you have prepared. Okay, let's recall the experiment. I'll tell you what the experiment is. You are taking copper sulphate crystals and mixing it with 250 ml of water, okay, and making copper sulphate solution. To this copper sulphate solution, what you are doing is, you are putting few drops, like 2 to 3 drops of dilute sulfuric acid so that it will be better conductor, and you are taking copper plates, cleaning them with sandpaper, and now you are attaching, you are connecting the terminals of the battery to these copper plates, okay, and you are immersing these copper plates into the copper sulphate solution. Did you understand? Now the current will be passing through this circuit, right? Now this circuit is complete and the current will be passing through this circuit. Leave it for 15 minutes. Okay, leave this circuit for 15 minutes. Now remove the electrodes from the solution and look at them carefully. Okay, what can you observe is, when electric current is passed through copper sulphate solution, copper sulphate dissociates. What is dissociation? There is copper and there is sulphate ion. Am I right? There is a copper ion and there is a sulphate ion. Am I right? So this copper sulphate was together, okay, bound by a bond. Okay, now what is happening is, it is dissociating. It means it is getting separated. Copper and sulphate is getting separated into ions. Am I right? Okay, this is called dissociation. When copper sulphate becomes copper and sulphate, then that is called dissociation. Did you understand? The free copper gets drawn to the electrode connected to the negative terminal, because copper will be positively charged. It is a metal. It will be positively charged. So it will be going to the negative terminal and it gets settled, deposited on the negative terminal of the battery or the copper plate. Did you understand? Now what is happening? The other thing, sulphate. What is happening? Sulphate is going to deposit on the positive terminal of the battery and gets deposited on it. I repeat, what happens is, when you conduct this experiment, copper sulphate becomes copper and sulphate. Okay, Now copper, which is carrying positive charge, will go and deposit on the negative terminal, and sulphate goes and deposits on positive terminal. That's so simple. Am I right? Okay. Now let's recall the experiment from the beginning. Now we have taken copper sulphate solution, okay, 250 ml of copper sulphate solution, and what we are doing is we are inserting copper plates which is connected to the battery, and now we are leaving it for 15 minutes. After 15 minutes we observe copper sulphate got dissociated to copper and sulphate. Copper gets deposited on negative terminal and sulphate get deposited on the positive terminal. Okay, did you understand the experiment? Let's study further. From the other electrode, a copper plate, an equal amount of copper gets dissolved in the solution. Okay, now what happens? The other rod, the positive terminal will be there. No, from there what happens is the copper on that copper plate will be dissolved. It will be the copper ions will be dissolved into the solution. Did you understand? The copper from copper sulphate solution is going to deposit on the negative terminal of the battery, the copper plate which was attached to the negative terminal of the battery, and if you consider the positive terminal, it will be giving out copper ions into the solution. Okay, the loss of the copper from the solution is restored by the process continuously. Okay, now it is taken from the solution and deposited on the negative terminal, and the positive terminal is giving out the copper ions, and there is a balance of this copper ions in the solution. But who is going to lose the copper ions? The positive terminal, right? It is giving out ions, right? Who is gaining here? The negative terminal, right? This means the copper gets transferred from one electrode to the other, to the negative electrode from the positive electrode. What it means? The copper is transferring from the positive electrode to the negative electrode. Am I right? Okay. This is a kind of electroplating. Okay. The process of depositing a layer of any desired metal on the other material by means of electricity is electroplating. Here if you see the word electroplating, electro is because of electricity, plating is giving a deposition, giving a plate around it, okay, giving a depositing layer. Okay, I repeat the definition of electroplating: the process of depositing a layer of any desired metal on another material by the means of electricity, by using electricity, is called as electroplating. It is one of the most common applications of chemical effects of electric current. There are a lot of applications, but this is one very important application of chemical effects of electric current. Electroplating is very useful process. It is widely used in industries for coating metal objects with thin layer of different metals. Okay, it will be used in a lot of industries. Why? To coat metals with other objects, okay, to get desired property. The layer of the metal will be deposited on another metal or another material to get desired property. I gave you an example of jewelry, right? When we talk about jewelry, there this gold plating will be done on another material. Why? To make it look like gold, right? So there should be one desired property of the metal which is depositing on another material, okay, which the metal of the object lacks. The object will be lacking the desired property. For example, silver is less shinier than gold and also less in the price as well. So what people does is, to make it look like gold, what they do electroplating on silver so that it looks like gold. Okay, this is the desired property I'm talking about. With this, I say bye.